Imagine this. You're standing on a beach 3,000 miles from the nearest piece of land you can see. No compass, no GPS, no paper map, just you, a wooden canoe, the open ocean stretching in every direction, and the stars above you slowly turning through the night sky. Now here's the question that should blow your mind. People did this. Not once. Not by accident. They did it on purpose, again and again, crossing thousands of miles of open water with nothing but their eyes, their memory, and knowledge passed down for generations. We live in a world where if our phone battery dies for 20 minutes, we start to feel lost walking to a restaurant 3 blocks away. So how did ancient humans cross entire oceans, deserts, and frozen wastelands without a single map? How did they know which way was home when there was nothing around them but water, sand, or snow? The answer is one of the most incredible stories about the human brain that most people have never heard. By the end of this video, you're never going to look at the sky, the ocean, or a flock of birds the same way again. Before we get into how ancient people navigated, let's sit with how hard this problem really is. We assume they probably just followed the coastline or didn't go very far. That's wrong. Dead wrong. Humans have been moving across huge distances for tens of thousands of years, crossing entire continents on foot, paddling into open ocean where you cannot see land in any direction, for days, sometimes weeks at a time. Walking across deserts so featureless that even today, with satellite images, they still look like an alien planet. In most of these environments, there is nothing that looks like a landmark. The ocean doesn't have street signs. The desert doesn't have exits. The Arctic, most of the year, is just an endless white sheet in every direction. If you or I were dropped into any of these places right now without a phone, we'd very likely struggle within days. Not because we're stupid, but because we've lost the skill set. Our ancestors had that skill set. It wasn't magic. It was observation, memory, and an absolutely staggering depth of environmental knowledge built over a lifetime. So let's start where a lot of this story starts. Up above us, in the sky. Long before anyone wrote down the word astronomy, humans were already astronomers. The sky was the most reliable, most consistent navigation tool available to them. The ground changes. Forests grow. Rivers shift course. Sand dunes move. But the stars stay basically the same. The sun rises somewhere in the east and sets somewhere in the west. That's gold for a traveler. If you know roughly what time of day it is, you can keep a consistent direction just by watching the sun's angle. The sun's position changes with the seasons too, swinging northeast in summer, southeast in winter. Ancient navigators had, in their heads, an entire seasonal calendar of exactly where the sun should be. Now let's talk about the stars, because this is where things get genuinely remarkable. At night, one of the most useful things in the sky in the northern hemisphere is Polaris, the North Star. Almost every other star appears to move throughout the night, because the Earth is rotating. But Polaris sits almost exactly above the Earth's axis. From our point of view, it barely moves at all. Ancient sailors in the Mediterranean, navigators in Arabia, travelers crossing Central Asia, all figured out this one star could be trusted. You just needed to know. That star doesn't move much, and when I face it, I'm facing north. But what if you're in the southern hemisphere? There's no single bright star sitting above the South Pole. So Polynesian and Aboriginal navigators used the Southern Cross constellation to estimate south instead. For ancient people, the sky wasn't just decoration. It was infrastructure, the world's first GPS system. Sailors developed something called star paths, memorizing which star rose in the direction they wanted to go. Across a single night, they might mentally track through 15 or 20 different stars, each handing off duty to the next like a relay race. That's not a rough guess. That's a precise, memorized system, more detailed than the basic compass most of us learned in school. Now let's talk about something jaw-dropping: how people navigated across open ocean, specifically in the Pacific. The Pacific Ocean is so big that every continent combined could fit inside it with room to spare. Scattered across it are thousands of islands, separated by hundreds or thousands of miles of open water. Polynesian and Micronesian peoples settled nearly every habitable island using double-hulled canoes and zero written instruments. No compass, no sextant, no map, So how did they do it? The answer starts with something most of us never think about: the shape and behavior of ocean swells. Wind blowing far away creates waves, but deeper, more consistent swells travel thousands of miles from the storm that made them. Skilled navigators learn to feel these swells through the hull of their canoe, through their feet, their hips, the rocking motion. Multiple swell systems can exist at once, moving in different directions, like hearing three conversations and following each one separately. Navigators could identify individual islands purely by the unique pattern of waves reflecting off that piece of land. Then there's the clouds. Islands disturb airflow above them and create distinctive cloud formations. A stationary greenish-tinted cloud can be a sign of a lagoon reflecting light upward, hovering over land not yet visible. Then there's the birds. Certain seabirds fly out to fish each morning and return home each evening. If a navigator spotted a bird flying purposefully in one direction late in the day, that was a strong clue land was that way. Add in the color of the water near reefs, floating debris, even the smell of land carried out to sea. These navigators weren't relying on one trick. They ran an entire layered sensory system all at once. There's a name for this body of knowledge in Polynesian tradition: wayfinding. It wasn't something you picked up casually. Navigators trained for years, sometimes decades, often starting as children, building a mental library as vast as our modern instruments. This knowledge nearly disappeared in the 20th century, replaced by modern instruments. There was really only one master navigator left who still held this deep traditional knowledge: Mau Pielug, from the tiny island of Satawal. In 1976, he agreed to guide a reconstructed voyaging canoe called the Hkli from Hawaii to Tahiti, over 2,000 miles of open ocean. He succeeded, and single-handedly revived an entire tradition of navigation that had nearly been lost forever. This wasn't primitive guesswork. This was an entire scientific system, refined over centuries, so effective it still works today. Okay, so we've covered the ocean and the sky. But what about land? In deserts, tundra, and dense jungle, land can be just as disorienting as open ocean. Let's start with one of the most extraordinary examples: the songlines of Aboriginal Australia. These are oral maps encoded into song, story, and ceremony, tracing paths across the landscape for hundreds of kilometers. A songline tells a story of ancestral beings, but embedded inside it is a detailed record of the real physical landscape: where the waterholes are, where a rock formation marks a turn, where food can be found in a given season. If you knew the song, you knew the route. The entire path was encoded, generation after generation, memorized and sung. This is one of the most sophisticated navigation and memory systems ever developed by any human culture. Songlines crossed language boundaries, connecting with other songlines maintained by entirely different peoples. Now let's shift to a completely different environment: the deserts of Arabia and North Africa. Experienced desert travelers read details most of us would never notice, like how sand dunes are shaped by prevailing winds. Certain plants only grow near underground water, telling a traveler they were near a wadi, a dry riverbed that only fills during rare rains. Just like at sea, desert travelers relied heavily on the stars at night, since desert skies are usually clear and unobstructed. But maybe the most impressive tool desert nomads had was memory, built through repetition generation after generation of the same routes. Trade caravans crossing the Sahara followed routes mentally mapped by countless traders before them, guided by desert pilots. These guides were so valuable that entire trade networks depended on their knowledge. Now let's go to the single hardest navigational environment on Earth: the Arctic. Flat, white terrain in every direction. No trees. Extended darkness. Blizzards that reduce visibility to a few feet. And the ground itself, sea ice, is not even permanent. It shifts, cracks, drifts, and reforms constantly. Inuit peoples developed navigation techniques so precise they could travel accurately across this shifting, featureless landscape. One fascinating tool was sastrugi, wave-like ridges carved into snow by consistent, prevailing winds. Experienced travelers could read these ridges even while moving quickly by dog sled, maintaining a bearing without seeing the sky at all. Some Inuit navigators carved coastline maps directly into driftwood, maps that could be read by touch, even in complete darkness. Inuit navigators also read animal behavior, caribou migrations, seals near breathing holes, for direction and clues about the ice below. Experienced travelers build an extraordinarily accurate mental map of enormous territories, built up over years of travel and stories from elders. Inuit hunters have navigated through complete whiteout conditions, relying almost entirely on this internalized sense of the landscape. At this point, let's step back, because there's something even bigger tying this whole story together: the human brain itself. There's a part of the brain called the hippocampus that plays a central role in spatial memory and navigation. Researchers studied London taxi drivers who had to memorize the entire complex layout of London streets to pass their licensing exam. The hippocampus can actually physically grow and change in response to intense spatial memorization and navigation practice. Ancient wayfinders, desert guides, Arctic hunters, and songline keepers spent decades intensely engaging with their environments from childhood. We tend to think of these peoples as somehow less capable. But the truth is the exact opposite. Navigation knowledge wasn't written down. It was held, refined, and passed forward through spoken word and lived experience. Becoming a master navigator was often a role of significant social and even sacred importance, earned through years of mentorship. Let's cover a few more remarkable examples. Nearly every culture that faced this challenge developed its own brilliant solution. In medieval Scandinavia, Vikings crossing the open North Atlantic developed techniques modern researchers are still investigating today. Old Norse sagas mention a mysterious sunstone that could reveal the sun's position even through clouds or fog. Researchers propose it may have been a calcite crystal that splits light in a way that reveals the sun's position even under thick cloud cover. Vikings also used a sun compass, a simple wooden disc with a central peg, similar to a sundial, to track the sun's shadow. In East Africa, nomadic herding cultures developed detailed knowledge of seasonal rainfall and vegetation cycles for navigation. In North America, indigenous peoples used rivers, mountain silhouettes, and animal trails as reliable waypoints. In Papua New Guinea, dense jungle terrain forced navigators to read subtle terrain slopes and plant growth patterns. How did people remember such enormous amounts of detailed information across long distances without ever writing anything down? Stories, songs, and rituals have a natural rhythm and structure, and human memory holds onto that far better than plain facts. Ancient navigational cultures had independently discovered some of the most effective memory techniques known to cognitive science. A young Inuit hunter wasn't handed a manual. He traveled the terrain over and over, alongside elders who corrected his mistakes. A young Polynesian navigator sat under the night sky, year after year, watching real stars rise and set, guided by a master navigator. This is a fundamentally different model of learning: slow, experiential, deeply relational. So why does any of this matter now, in a world where everyone just taps an address into a map app? There's a growing conversation in cognitive science called cognitive offloading. When we rely on tools, our own brain skill can weaken from lack of use. This doesn't mean GPS is bad. It's incredibly useful, but it's a reminder of just how much raw capability the human brain has. There's enormous value in preserving traditional navigation knowledge before it's lost forever. That story with Mau Pielug could easily have gone the other way. An entire body of knowledge could have simply vanished. Every system in this video was developed with no satellites, no computers, just patient, careful observation of the natural world. So the next time you glance at a little blue dot on your phone, remember what we just went through. They didn't have maps, so they became the map. Thanks for watching, and I'll see you in the next one.